Hi guys, welcome to the ICA Electrosyn 2.0 video user guide. And right now I'm going to show you guys how to operate the Electrosyn to take the cyclic voltammogram. And if you purchase the Electrosyn 2.0 Pro package, or if you've separately purchased the CV package, I'll let you know what you can do to use that to take a CV. And so if you purchase these packages with the CV setup, what this includes a reference electrode, includes a counter electrode that's a platinum coated electrode, and it also includes this 3mm glassy carbon disc working electrode. And all of these should attach to any of the Electrosyn vials via the standard electrode connections in the top of the vials. So for this one, we're just going to use this small one here, but really you could use any size. So the first thing you want to do is you want to prep the reference electrode. And what the reference electrode is it is a silver wire that's encased in this little glass tube with a glass frit right at the bottom there. And this is really nice because it allows the user to run a reference electrode using a variety of different solvents and electrolyte solutions based on what type of CV you want to do. And so a really standard solution is just an aqueous solution of 3 molar potassium chloride. And what we've done here is we've filled that up with a little bit of 3 molar potassium chloride here, and then we just want to stick that silver wire in there, get a nice snug fit with that little stopper. And what you then want to do is, we've set this up before, but you want to soak this for a little while in that electrolyte solution. And the purpose of it is to really permeate that solution throughout that frit, so you can get good current and salt flow when you want to take a CV. Now we've used an aqueous solution here, but this is compatible with a number of different organic solutions as well. And really the important thing there is just using an electrolyte that is sufficiently soluble in that solvent, so you can get a nice CV and you don't have resistance issues. Okay, so we've already prepped the reference electrode. What we want to do is we want to screw this in to this port here, and we just want to screw this in until it's nice and snug. Make sure that rubber septa is nice sealed. And next thing we want to do is we want to put in the working electrode. And as I pointed out before, at the top of the cap we have a W and we have a C, and that corresponds to working and counter electrode. So the working electrode is this 3mm glassy carbon disc electrode. We want to make sure that's in the W side. So we're just gonna snap that in just like on the other electrodes, and on the counter electrode side we're gonna put our platinum coated counter electrode. And again, just like the other electrodes in the other videos. Okay, so with that set up, we can now screw that onto the vial. Okay, that's in there. And what we're gonna do is we're gonna take a CV of Tempo. So you have a really dilute solution of Tempo in acetonitrile with 0.1 molar tetrabutyl ammonium tetrafluoroborate. And so you can put this through the top here, through a septa. Let's say you have something that was really sensitive, or what I'm going to do is I'm just going to put this in here, make it a little easier. And so let's fill up some here. And for the solvent level, really the only important thing is to make sure that those tips of the reference electrode and the working electrode are fully submerged enough so you don't get some issues with the current not being able to pass because they're not submerged properly. Okay, so I'm going to screw this in. I'm going to make sure that those are properly submerged. Let's clip this onto the Electrosyn and let's turn that on. Okay, so there's two ways you can set up a CV experiment using the Electrosyn 2.0. The first is we can go to New Experiments, click on New Experiments. We already run through how to take constant voltage or constant current experiment. We get on a cyclic voltammetry, and we get to the CV start menu. Now alternatively, from the home screen, what we can do is just press the CV button, and that again brings us to the CV home screen. And so first off, what I'm going to do is I'm just going to take a CV using the default settings. So we're just going to, as easy as just pushing the start button. And once you push that, it's going to start recording data. It's not going to display it until it starts to actually record it for a little while and do that post data collection processing. But you notice this blue line at the top pretty much indicates that the CV is running. So now it's started to collect it, and it's going to start to display our CV data here. So this is a CV of Tempo, and Tempo has a reversible oxidation. And so what we see here is this is the oxidation of Tempo. On the back end, the negative side, we have the reversible reduction of that oxidized Tempo species. You notice here we have two other bumps there, and those are likely the reduction of oxygen gas and carbon dioxide. So we really haven't done anything to exclude water, moisture, or oxygen atmosphere from this. And so because of that, we're seeing these two artifacts likely due to oxygen and carbon dioxide. So this looks nice, but again, let's say we wanted to put this in a paper and we're looking at the oxidation of our analyte Tempo. This is all really around here. We don't really care about what's there. So I'm going to show you how we can go and we can modify the CV settings, the CV parameters, to get a more custom, finely tuned CV curve. And so we just put the back button, and from the CV start menu, we want to go to edit, click on edit, and in this edit screen, we're able to control all of the different parameters needed for taking a CV and really custom tune it to exactly what you want. And so for normal CV, the number of segments is 3, and that corresponds to from the start, going all the way up, going all the way back to the second, and then back to the start, that's 3. The initial potential we've set at 0. The direction, that corresponds to really the direction from the start. As you've seen the CV we just took, it was rising, being that it started at 0 and it went in the positive potential range. The upper potential and lower potentials is pretty much the high and low end that it goes, and the final potential is where it ends, and the sweep rate in millivolts per second is how fast we scan through the potential range. So as you said before, we are seeing the reduction of carbon dioxide and oxygen, and we really wanted to clean up this CV and not show those, and so all we're going to change is we're just going to change the lower potential, and that was set at -2, and we're going to do that to, let's change it to -0.5. To change that, click that again. We can check through to make sure everything else is good to go. And with that, we're going to push the back button, and now we're going to go hit start, and it's going to take a CV using those modified parameters. Again, you see the blue line progressing over here, and that means that we are recording data, and it'll start showing it momentarily. Okay, and so there we see the oxidation of Tempo, and coming back around, that reversible oxidation, that oxidized form gets reduced. And now at about -0.5 it stops, and this brings us back to 0. So here we have a nice CV curve. We could say publish this in a supporting information section of a paper. So one final thing left to do. Let's say we have a nice CV that we're satisfied with, and we want to export this to a computer to say, make it look nice, to put in that supporting information. Shortly, coming out somewhat soon is going to be the ICA Electrocyn 2.0 app, which is going to allow you to do a lot of these things wirelessly and a lot more kind of post-run processing. Currently, real easy solution we have is we've included these little USB sticks, and what you want to do is on the end of that we have a micro USB, and in the back here we've got a little lid, if you can see it there, and you can plug that micro USB in, and now we can go click save to USB, and this is going to save it as a data file that we can just plug in our computer, and we can open that up in Excel or as it comes out in the Electrocyn 2.0 app. So I'm just going to save that as ICA CV. Click OK, and now it's saved. So later on I can save another CV, I can save other experiment parameters, and then I can go on my computer and I can look at that data that way. So thanks a lot, guys. If you have any other questions, please feel free to tune into the other videos. Enjoy the Electrocyn 2.0.